Good afternoon, everyone. My name is Ijaz Jamil, Chief Architect at Soalib. First, I'd like to thank all of you for your participation in this course. This will be one-hour session, which will discuss essentials of service-oriented architecture security. I hope that you can all hear me. You are already looking at the first slide. This slide provides an overview of various parts of web services and their relationship to others. This course is about SOA security, so we will include both web services security and XML security. In later slides, we will see deeper into what's really happening. Okay, I got a confirmation that you can hear and also see the slides. So let's begin our security webinar. I'll go to page 2 of our slide. Please ask me any question if you have. Interrupt me and I will try to answer the question right away, or I will answer it when we get to the question and answer session. In this course, I have tried to get towards SOA security by first discussing basics of networking and then discussing various security key architectures as their standardizations. Transport level security is then discussed. Secure tunneling and firewalls were then covered briefly. Then we entered into the main discussion, which is data level security, which is the message level security. XML security is then covered, various WS security standards, and their operation is then discussed with definition and operation of security tokens. WS messaging and WS transactions are discussed and their basic operation covered. Discussion of various WS implementations related to various WS standards are then discussed. Finally, we discussed with the REST service security. Let's move on to slide number 3. Network protocols. Let's first discuss the root of networking, the TCP and UDP protocol. From now on, I will use the word TCP, but consider that it also applies to UDP. All networks today use TCP packets. These are small packets with only several kilobytes in size or smaller. Most TCP packets refer to 32-bit addresses, which we call IPv4. The industry has been trying hard to popularize the IPv6 format, which have 128-bit address size. But 128-bit addressing is only used in intranet, not on the internet. Each TCP packet carries the source and target and port information. The data that is being sent is unchanged during transmission when it is at the physical layer. Slide number 4. Well, here we see a TCP packet. In this slide, we can see what a TCP packet look like. The table on the right is the way how packet is organized. So you see a table here, a packet here. This is the way a packet is organized in a TCP. The beginning of the packet have a source and target information. Here we have a source and target information. After 32-bit address, this is 32-bit and 128-bit address. So for IPv4, this is 32-bit. For IPv6, these are 128-bit addresses. The protocol and packet length is then assigned. Each connection to a network must be over a network port, which is assigned in the packet next. The sequence number and acknowledgement number is done by the physical layer for delivery assurance. The final part that I would like to focus on in this is the data part, this part. Notice that this data part is what the application provides. This packet have no knowledge of what kind of data is there. So this data is actually just plain data. What we are getting from here is that TCP protocol is simply a protocol for transporting data from one address to the another and nothing else. It is the responsibility of the application to provide the data security if security is what our concern is. So if A intends to send data to B this way, then it simply puts the data in the data area of the packet with other required information, and B will get the packet. If A intends to send data securely to B, then it must encrypt the data some way when it puts the data into the TCP packet, so that anyone listening to that network cannot figure out what the data mean. Slide number 5. Basic networking. In basic networking, all simple networks like what showed in the last slide is connected using routers. We have routers here. This router is connecting to various networks. The router forms a bigger network by connecting smaller networks. The gateway creates even bigger network by linking to the intranet or internet. What are we noticing here? Let us think. This is what we see. The entire TCP connected world is insecure. So the entire world of this networking is insecure, and that every node in the network A, B, C, and D on the network can listen to what's going on in the network, because it can listen to the network and grab every packet that passes by and read any data that is in the data area of the TCP packet. Although some isolation is done by a router by isolating the network composed of A and B and also composed of C and D, so C and D packet will not pass to D in this area if the packet is designed for A and B, C and D. So although some isolation is done by the router by isolating the network composed of A and B from the network composed of C and D by blocking the packets that does not have A and B address originating from C and D and vice versa. But this is not the security we want. If that is the case, then isn't it that security is extremely difficult job in TCP protocol and somewhat proprietary in nature due to application data level security? In TCP, we are dealing with application level security. Page number 6. Now let's look at what is network security. Let's try to answer that question. In this slide, we are trying to secure the connectivity between A and B, which we were communicating insecurely before. In order to secure the communication, we put a security layer over the data that is fed to this network such that A and B. So here we have added security layer. But see, other than adding the security layer in the network ports, there were no other change. The data packet remained the same. There is, however, one additional change. We have now assigned a new port over which the communication will occur. So these ports are secure ports. In the past, we were using insecure port. Now we are using a different port called secure port. This is the reason you will notice that secure ports are different than insecure ports. At the firewall level, the insecure port is blocked and only the secure port is exposed to the internet or the internet, because now that we have to come up with some agreement between A and B in order to understand what data has been sent to each other. We need some kind of standard because each of these A and B are encrypting the data. Slide number 7. Type of security. In order to come up with some standardization on encryption, 3 major ways were proposed. The first is the symmetric key encryption, in which a single key is used to encrypt and decrypt the data. The most popular algorithm today are DES, which is Digital Encryption Standard, which stand for and also AES, which is the Advanced Encryption Standard. This algorithm implementation is available almost every popular programming languages. The main problem faced by symmetric key type of algorithm is that if an eavesdropper somehow finds the key and the owner of the key have no idea if the key was found, then decrypting the data isn't as easy as putting the key into the algorithm. The second reason why this encryption is very unreliable is because there are hardware and software developed to determine the key from known plain text pattern and brute force search. In order to solve the key problem, asymmetric key encryption is used. In asymmetric key encryption, the key used to the data cannot be used to encrypt the data. To decrypt the data, a second key is needed. The advantage is apparent in this encryption that even one knows about tone key, they have to find the second key. So in an asymmetric algorithm, there are 2 keys. If one of the key is missing, then it cannot be decrypted. So the difficulty is, I'm receiving a question here. Example support might have, okay. Yes, Mike, the secure port for HTTP is 443 and insecure port is port 80. That's correct. And so I was talking about RSA, and in RSA that even one knows one key may have to find the second key to decrypt the data. Usually one of the keys is called the private key, then the second one is called the public key. This key is supposed to be kept hidden. The private key is supposed to be kept hidden. The transport layer security, or TLS, is an upgrade from SSL algorithm, which is based on asymmetric key architecture. On top of that, transport layer security adds a handshaking protocol from which the two ends may exchange security data in order to agree on key algorithms. Now let's see the security architecture. Slide number 8. This is Asymmetric Key Cryptography. We have insecure data coming from here and one end, and we have a secret private key here, and there is a DES and AES algorithm, and the output of the algorithm is an encrypted data. The streams are in blocks of 64, 56 bits, 64 bits, or 128 bits, which repeats until the data is entirely encrypted. If the encryption does not end in a boundary, then paddings are used to actually end the entire data in a word boundary. Slide number 9. This is asymmetric key cryptography. In symmetric asymmetric key cryptography, we have key pair generator to start with. So we have a key pair generator that generates public key and private key. The key pair generation is associated with the algorithm. That means if we use RSA, which means Rivets, Shamir, and Adelman, the last name of 3 researchers at MIT who invented it, then the key generator must generate keys for RSA algorithms. Keys are not compatible with algorithms. So RSA have to use RSA key algorithm. These keys are large prime numbers, usually over 1024 bit or over up to 2048 bit prime numbers. Once these key pairs are generated, one key is kept under one application as a private key. Then generating the TCP packet in secure data is passed to RSA algorithm using the private key as in A. So we have this private key actually going into 2 encryption and decryption method. And we are getting an insecure data here, and then we are actually signing the insecure data with RSA private key, and we get a secure channel here in this orange area. When it gets to the other end, which is B, actually tries to verify it with its public key, and the output becomes the insecure data again. And on the other way, it does the same thing. So we have it in signature signing here, and then verification here, and then we get that. So you can see that if I have a private key, I have to decrypt it with a public key, and if we have a public key, we have to decrypt it with a private key. Notice that we have one of the key assigned as private key and the other assigned as a public key. The reason is that A would like to keep its private key secret and allow other to disclose the other public key. If the public key is not disclosed, then B will never know. If the private key is not disclosed, then B will never know what the private key is, and so this kind of asymmetric algorithm is fairly secure. Slide number 10. In transport layer security, uses asymmetric key encryption in addition to a handshake algorithm so that transfer of key agreement is automatic, and the protocol to be used during secure communication can be done automatically. Once the TLS session is initiated, the entire connection becomes secure. But remember that the fact that it's still the TCP packet which everyone can grab. You know that we saw that TCP packet can be grabbed by any port. Because public key is known, there are ways to find private key if the prime number used to generate the key is not large enough. I mean, it is not truly entirely impossible to actually get the private key if public key is known. The bigger the prime number is, it is more difficult to find the private key, given you have the public key. But at the same time, bigger prime numbers causes more processing delays and more time to actually encrypt or decrypt the data. But know the fact that there are brute force and search algorithms that are out there which actually can find the private key if the public key is known. But it takes longer and longer time as the size of the prime number becomes bigger and bigger. Slide number 11. Here we are seeing some commercialization of TLS, transport layer security. In order to commercialize the use of transport layer security and using it as a standard for secure communication, certificate authority were born. These guys were born. Their job is to sign these public and private keys using digital signature algorithm, DSA, in addition to some other data like company information. Like here you see the company name, common name, organization unit, locality, state, country. All this information is then used to create a security certificate. So the security certificate is a piece of binary data with information combined with these public key and private key, which is simply a stream of binary data often represented in hexadecimal format. This certificate is placed in a certificate storage area called key store in the server, which is usually a file. The key store is a file. The server gets the private key from the key store, but the client can never get the private key. But they can request a public key. In our diagram, see, the client is requesting the public key. The key store will give the client the public key, and they will be glad to. It will be glad to give the public key to anybody. If in our diagram A is the server and B is a browser, then to initiate the communication, B first gets the public key from A and checks if the public key is in its trust store. So this is the browser, for example. It gets the public key and sees if the public key is already in the trust store. The trust store is a file which keeps trusted public keys. Now, if the public key of A is found, then the usual transport layer security will begin. Otherwise, B prompts to the user to accept the public key or reject the public key of the credential and displays the credential of the public key, which is the public certificate. So you can see that if you go to a expired certificate, a site with expired HTTPS site, you would usually see a display like, say, the certificate has expired, or if you want to trust it. So that's what really is happening here. Transport layer security is one of the most popular and presently free and secure way of communication over the internet. Transport layer security may be thought of as creating a secure tunnels. Slide number 12. Now let's discuss about secure tunneling. Secure tunneling is a way of creating tunnels with data encryption, similar to transport layer security. However, unlike transport layer security, which creates point-to-point secure tunnel channels, other tunnels are devised like VPN tunnels, which connect two networks over a secure channel such that the two network acts as a single virtual private network. So we have two networks. If we have two networks, connecting them with a secure tunnel actually creates a new virtual private network. SSH uses transport layer security to create secure SSH tunnel for remote locations, but it can also be used for port forwarding and create an SSH VPN. HTTPS uses transport layer security to point-to-point secure tunnels. There are other VPN tunnel algorithms and protocols which we are going to discuss now. VPN tunnels. Slide number 13. VPN tunnels secure the entire communication path like transport layer security, but uses some other forms like IPsec, which stands for IP security, and LTP, which stands for Layer 2 Transport Protocol, and other protocols are also used because these protocols are easier to implement in hardware. VPN routers are used to connect two insecure networks such that the two networks act as a virtual private network. Slide number 14. Firewalls. Firewalls are a well-known security instrument today, and let's see what it is. Firewall attempts to secure network at limiting access to resources. Firewalls may limit access to certain network ports. During our discussion of TCP packet, we said that the packet can obtain IP and port information of any ongoing packets. By checking the packet, the firewall may block the packets from any unknown IP or ports. A firewall may also make a port read-only or write-only. In addition, firewall may also be made application level by limiting some application access network connectivity. For example, application that attempts to connect port number 22 of certain server can be blocked by a firewall. Firewalls may also limit at protocol levels by limiting port access by some programs. Like, for example, SSH programs cannot be used if the firewall does not allow port 22 access. Proxy server is a method of creating firewall on a web server so that all external connectivity is passed through that server. HTTP proxy server is commonly used in a large corporation where the proxy server blocks all unwanted traffic and secures the network by not allowing direct access to port 80 of a foreign server. The foreign server is any server that is outside the intranet. Firewall may also be used for host level authentication by checking the DNS server for IP addresses and then validating the connectivity if it finds the IP address in the DNS. So this is another level of firewall security, that any external server that is trying to connect to a PC or a server, the DNS can be looked up to check if that IP address that is coming through that TCP packet is already in the DNS address. If it is not in the DNS address, then the firewall would reject that request. There is also XML firewall, which is a data level firewall and usually in XML and uses XML level security authentication. We are going to see XML security very shortly. Now we come to data level security in slide number 15. And data level security. Transport level security does not deal with application level data encryption. All data is encrypted, whatever is passed through the channel. This may be okay for most applications, but it is not the desired way to create secure channels when communication is based on messages. Now, as you know, in SOA, communication is based on messages, and nobody knows how the transport works. The transport may be FTP, HTTP, JMS, so there are so many choices of transport we can use in service-oriented architecture. And that's why transport level security cannot be used. It can be used, but is not the desired level of security. We want data level security. Data level security is to ensure that only the data is secured and does not really care if the communication channel is secure or not. When most of the communication is message-based and asynchronous, then TLS, which is the transport level security, is not suitable because messages come at different times and are predictable, and also SOA services are autonomous, and therefore message level security is what we need. The source of the message, may not have transport layer capability. For example, if somebody is sending the message using a flat file, the flat file cannot be, we cannot guarantee any kind of transport layer security on a flat file. So we need message level security so that the data in that file is secure. Slide number 16. XML Security. XML is a universally accepted format which may be used to represent any kind of data, text or binary. XML security algorithms are also standardized before WS Security 2. So XML encryption standard and XML signature standard is used during XML validation. SAML, which stands for Security Assertion Markup Language, is a security assertion language used extensively in WS Security and usually associated with token generation. So in this slide, A is sending an XML document. So A is sending an XML document, and through XML encryption over a plain TCP packet, the data remained encrypted over a non-TLS transport, regardless of it is a TCP based or non-TCP based. It doesn't matter. It doesn't have to be a TCP based protocol. It can be a file based protocol as well. As far as REST services is concerned, only XML security is available because REST services are URI based for service endpoint, and data is transferred usually using XML. The data portion may be digitally signed and encrypted using various XML security standards. Alternatively, HTTPS protocol may be used for transport layer security, or both can be used together. Slide number 17. Digital signatures. Digital signature is a way to ensure that a message content remain unchanged until the message is delivered to the target recipient. The XML message is signed by possibly digital signature algorithm, which is shortly called DSA algorithm, or its derivative algorithm. There are other algorithms derived from DSA. The message is then sent over various other protocol. If the message is read by an unauthorized party and the content is changed, the signature will not match, and that causes a rejection of the message. On the other hand, if the signature match, then it's a guarantee that nobody have changed the message. So this is the right kind of signature we have to deal with when it comes to WS Security, because WS Security passes through many intermediate layers of other services, and only digital signature ensures that any other intermediate layers has not changed the original data. Digital signature is used extensively throughout various WS Security protocols due to autonomy of web services. Only digital signature can ensure that the data and the message contained is unchanged. Now let's focus on web services security. The so-called web services security standards are created in order to interoperate across web services. How much success have been achieved from these standards are difficult to say, but the attempt to standardize these things was a good effort. But most of these are still not well understood by the customers or consumers. Many of the standards acceptance are somewhat of a choice of a service developer. For example, WS Security is independent of WS other standards and displayed in this slide. Each of the other standards like WS Secure Conversation is a protocol for handshake algorithm, just like TLS, which uses handshake before a secure session is initiated. WS Secure Conversation is a protocol which may be used to create a secure messaging session. WS Trust may be thought as a protocol that attempts to create a trust store equivalent to what we saw in the commercialization of TLS. The difference is that in our previous discussion we had a trust store which is a file, but in the web services everything is either service or message. So WS Trust extends WS Security Protocol and adds the trust validation protocol so that the service is able to validate the security token that was passed by the client. A security token may be thought as a security unit, which we will see later. WS policy is a general XML template for security policy document. It is not a protocol, rather it's a schema. Based on that schema, WS security policy is designed to create security policy documents. Security policy documents are used by WS Trust to determine the security policy. A security policy document describes the current security accepted by web service, like for example if username token is required or a XML token is required, encryption, what encryption algorithm to use. Security WS policy attachment is used to attach a policy to the WSTL document so that the security policy may be obtained directly from the WSTL. Now, there has to be a way to find where these policies are written. WSTL is one of the sources where you can find where this security information is written. WS Federation is a protocol to communicate and validate security tokens among multiple security token service. The security token service, as we say, the security token service is a service that generates security tokens for use in messages when a client requests to obtain proper credential. And we are going to discuss security token next. What is really WS security? Let's discuss security token first. A security token is a unit of information. In this slide, an overview of web service security is actually described, which actually says the security token is an important concept in web service security. The security token should be thought as a security unit. A security token means a handle to an entire suite of security for a service that can be used. The various kind of security token used by web services are like a username token, SAML token, X509 certificate token, and then REL token, Kerberos token. Username token is exclusively used for username and password validation. In web services, we just need a one-time validation. Once the token is validated, it doesn't have to be validated again. Once validated, STS returns a token. So STS, we have a security token service which actually provides these tokens if the client requests it. So in this example, in this diagram, the client is requesting a token. If the request is accepted, then it will get a signed token, and this signed token is then used for later conversation with any other services. So here you can see that client is passing that token to the service, and the service actually inquires STS to see if that token is valid. As we have already seen that a token is requested by a client, which may well be a service itself, requests a security token by passing the required information as requested by the desired token. If the token If the request was validated by STS, then a token is generated and signed by STS and sent to the client. The client uses this token for all communication in the service. In each communication, the token is passed as header and the data encrypted based on the token. All this communication channel is therefore encrypted. Slide number, let's go back to slide number 18 because we skipped that to describe the security token part. Now let's go back to what are the really WS security standards. Different kind of security are there in WS standards. This slide gives an overview of web services security standardization. Now relate this diagram to what we have learned in the commercial transport layer security. We have a web service A, which is this, intended to communicate with another secure service B. But A have no idea on how to communicate with B because it does not have the required security information. So service A first contacts the service registry of B. Service registry to get the information about B, the WSDL of B. In the WSDL of B, A finds the token information and also the information of the security token service, which is here. So A then sends a message to the STS. So it's sending a message to STS, and it passes the username and password with it. The STS validates that information and sends the service A username token. It grabs that token and creates a WS security header with that token and encrypts the data in the SOAP message with the public key it gets from STS. A sends the message to B. B validates the digital signed message, and once this channel is created, B now trusts A. But this is a grossly simplified view of the overall web service security. The communication between A and STS is defined by WS Trust Protocol for each service. In addition, A must also know about the security policy of B, which it gets from the registry using UDDI. The WSDL may contain the security information. We already discussed that, so we go to slide number 20. Standards for messaging. The messaging is not directly related to security, but there are some things I'd like to discuss about reliable messaging. WS standards are created also for messaging. SOAP is sent as a message itself. So the question may be that why is there another messaging? WS reliable messaging in the WS standards is an attempt to create a JMS type messaging with delivery guarantee. Now, as you know, that JMS is a messaging API that actually guarantees message delivery. It is a protocol. Now, reliable messaging is a protocol that has various validation in it in order to guarantee a delivery when the message is received by the target. WS reliable messaging policy is a policy document usually attached to the WSDL or as a schema to describe the policy of the messaging standard. WS eventing is used for event processing, is not very used recently. It is not a protocol that is extensively used. WS transfer is a way to get some kind of connectivity to REST services because it allows get, put, delete, and post messages to be passed to HTTP protocol. Slide number 21. Now we were talking about messaging standards. Let's see what is really about. In this slide, a SOAP message is shown carrying various messages in service B. So a SOAP message, everything is sent through SOAP messages. So if I want to transfer, the transfer packets is sent through, eventing is also sent to, and enumeration is also sent to through these packets. Now these messages are not sent in a single packet. A WS transfer packet will have WS transfer header in WS addressing. So each of these will have its equivalent header in the SOAP header package. So in this slide, a SOAP message is shown carrying various messages to service B. Not all messages are sent as a single packet, but in a sequence. Web services messaging somewhat falls into the web services security domain due to the reliable messaging part. In order to obtain reliable messaging, it is not just assuring delivery guarantee, but also pass the data in XML format with digital signature. I have received one question, Jaitin. I will answer your response after I finish this webinar. We have about 5 minutes to finish this. WS coordination. This is a transaction level security. What I would say is a WS coordination. WS standards for a transaction are a set of standards that attempt to create a transaction. A transaction is a set of operations done together, but the transaction is not considered complete until all the operation related to that transaction is complete. So if one of the transaction in a dozen of transactions that has to be processed in a web services transaction fail, then the transaction is considered as failed. Once all the operations are completed, the process is called as a transaction complete. A transaction may be considered as an atomic transaction when the transaction is done in a short time. WS business activity is considered as a long duration transaction. WS coordination is the actually protocol. It's the main protocol that actually manages these transactions and does all the messaging between and across the various services to actually manage the transactions. So let's see what happens here in the transaction level. In slide number 23, we're seeing that A is trying to do some transaction with B. Now let's say in this slide we have shown that what is a transaction is like. Let's say that A calls B 10 times, 5 times let's say. Calling less than that does not constitute as a transaction. So A and B exchanges WS coordination messages and keep track of how many calls been made to B. Upon completion of 5 calls, B receives a WS coordination message that says transaction is completed. A also receives a coordination message saying that transaction is completed. So now the transaction between A and B is completed. So each of those are given that message. SOA application security. Now, so far we have discussed WS security, which is the web services layer security. Now let's say that what we can do internally in the application itself. Applications can have its own security. Even after using all the security offered by WS security standards, the SOA application itself should provide some kind of its own security. SOA service is an application, and therefore a number of security should be implemented. If the security required that certain user authentication is desired, then it should check it. Sensitive data must be stored in encrypted format. For example, in file or media like email, we cannot send real data. We have to send data in encrypted form. Session timeout protects the service from unauthorized use when in idle. Idle instance may be determined from session timeout, and the instance should be destroyed. And as you know that web services are instance based. When a client calls a web service, an instance is created. But when the instance is destroyed depends on actually session. A service should detect infinite loop, which may happen if a bad programming is done or if something is done intentionally. Now, this is one of the danger part of web services, that web services can be continuously fed by messages. Bombarding services with messaging actually loads the services. Services should detect loops and duration in order to see if these loops are valid. Now, services can be a problem when you have messages that is actually continuously getting messages but not validating any messages. Runtime secure tunneling should be created for any external resource access like databases. A service may also track what exceptions are thrown most of the time. Some exceptions may be critical than others. If critical exceptions frequency is more than the other exceptions, then the critical exceptions should be actually determined and actually found if those exceptions are really intentional or unintentional. Let's go to the next slide, WS implementation. This slide just says that Java and .NET have implemented various level of security. As you can see here, various level of security is being implemented by SOAP, by these libraries. Like WSIT is the Java side, and WCF, Windows Communication Foundation, is the Windows side that implements all this security. This concludes the webinar, and I will actually go into detail of answering the questions and the number of questions I am receiving here. The first question, slide number 6 example, okay, that I've answered. Could you talk about the maturity of these various X standards and XP? Okay. The one question is that what is the level of maturity the industry have reached on WS different standards? The maturity is growing, gradually growing, and as you can see that maturity of these models come with the tools. Somebody have to develop the tools because this takes a long time to develop. Windows provides WCF standards API, and Java provides the WSIT now because these are already implemented. These standards are already implemented in this API. So now most of the web services you will see coming in 2009 or later will have these WS standards already implemented. And what is the other question? As these are so many WS security standards, is there a way to say the order in which to approach? Yes, that is a very good question. What is the best? What are the things that have to be implemented in a security today? And you can do something tomorrow, so you can have something out as quick as possible. Now, these are the things like SOAP, WSDL, and WS Security. These three are the most important area that you have to focus on. Let's show you in a slide and what is really required. In this one, we're talking like a SOAP and WS Security and WSDL. These three are the standards you cannot escape. You must provide WS Security. Now, to implement WS Security, sometimes you need to have a WS Trust. WS Trust. Now, WS Trust, you do not really need to have it implemented in your first version of SOA services. but in later version you probably need it, because otherwise if the WS security does not have a trust inside, then the security certificate transaction, the transfer of security tokens, cannot be actually used in WS Security. You have to manually provide the security token to your customer. So that is okay, I think. If you are okay, if your customers are okay to get that manually from your vendors, I mean from you, and then that's okay. In later versions, you can use these API that I showed you in the slide, Java or .NET API, to implement WS Trust and also WS other WS standards like secure conversation and reliable messaging together. Now another question is also, is there a location where I can find the recording of the webinar? Yes, you can certainly find this webinar is getting recorded. If the recording is okay, then we are going to put that on our site. You have to log into the site. You have to sign up and log into the site to actually see the webinar and also get the slides. The slides and webinar are going to be in the same page. And you can also actually view the entire webinar again if you want to. Also, okay, do you offer any more in-depth session? Yes. Mike, yes, I do have an advanced version of that session where I provide how to actually develop WS Secure Web Services. Now these are not going to be free. They're offered on site in Massachusetts. It is coming in July, where our seats are somewhat limited, but it's basically a 3-day course showing you how to develop web services with WS Security, different kind of security built into it. So you are basically going to master how you can create your own WS standards-based security with the latest API that just came out. Like for example, let's go back to that slide again, like these. We'll focus on Java. The course will focus on Java. .NET is going to be also provided later, but I believe that some companies have some bias toward Java because Java have a lot more open source offerings than .NET. So most people actually do develop a lot of their web services using Java. And also another reason for going for Java is because of GMS, because a lot of companies out there are actually using GMS for their messaging. There is another question, a follow-up. I understand correctly. Okay, let's see. I have to expand that. If I understand correctly, WS Security provides message level security, which WS Secure Conversation provides secure session establishment. Doesn't that make WS Secure Conversation one of the essential standards for writing a basic secure service? Well, Jatin, here is the thing. WS Secure Conversation is used when you implement STS. WS Secure Conversation is not really required for WS Security. WS Security is a message level security for which you do not need WS Secure Conversation. WS Secure Conversation is required when the token is established. Now, because in the first version or first 1 or 2 version in your web services, you will not be using any other methods of communication. If you do that, it will be great, but it takes time. If you have to learn from these, like from a company or from experts, how to actually write WS Secure, the latest standards. Like here I'm showing on the screen, and these security stack, security web service, really following all these standards. If you just do web services security, then you do not need WS Secure Conversation. But if you have STS and other WS Trust and WS Security Policy, and also WS Policy, which is actually extension of WS Security Policy is the extension of WS Policy, that's when you need WS Secure Conversation. Let's see, I have more questions coming in. Got it. Okay. All right. Let's see if there are any more questions out there. Feel free to send me questions because this is the question answer session. I am actually, let's see, there is one more question. Okay. No, there isn't. I have answered that. Okay, so I guess that there isn't many questions. Tomorrow there is going to be another webinar that's focusing on data synchronization using service-oriented architecture and also data services. If you are interested, go to soalib.com and sign up for that session, and I hope you will enjoy it. Those who have came later and missed the first part of this webinar can actually log in by Friday. Before Friday, actually, we are trying to put the entire, all the slides and all the video information before the coming Friday, so you can log in into the site and see the webinar if you missed anything. If you have further questions, send us email at soalib.com, soalib@soalib.com. Let me write down the email address here, so you can send us some information if you, whatever you want to send, if you have any question. So soalib@soalib.com, you can send emails. If you send email about some webinar, I will get access to that email. It will be forwarded to me. Thank you for attending this webinar, and I hope that you will have a nice rest of the week. Thank you.